Hello folks, this is 2024 October November paper 1-3 and the question number is 35. It is concerned with the chapter current electricity. So it says that the diagram shows part of a circuit which that uses a potentiometer. So this whole circuit is a potentiometer wired to measure a potential difference in an external circuit. Okay. The potential wire XZ has length L1, so it shows this. So XZ is this, X and Z, whose length is L1. It says so. It says so. It is connected to a cell of unknown EMF source, EMF E, that has a negligible inner resistance. So this is the master cell, we often call it as. It doesn't have any inner resistance, it says. That is for ease. Then terminals P and Q are connected to the external PD to be measured. So P and Q are connected to a external source. Let us say I can connect it to a source like this. So this is the source. That is what it says. So to measure the length of the potentiometer wire between X and Y is L2. So to balance it, we have to adjust the length L2 as this, L2 between X, Y. The ratio of lengths L1 and L2 is used to measure the PD between P and Q in terms of E. So this ratio of this length and this length is used to measure the PD between P and Q, measure the PD between this thing in terms of this E, in terms of this E. That's what potentiometer does. Which condition must be met in order to determine this PD? So we have to find which condition that is to be met. So what we have to remember is, during the potentiometer circuit and use of this circuit, you have to connect the source like this, the other source like this, and you also have to connect an emitter or any other meter like this, Now, when we exactly measure the EMF, what happens is at that time, this E should be set equal to Vxy, should be equal to Vxy. And that happens only when the current in this part is zero. The current in this part is zero, which means this current here is zero. The current here is zero means that the current here is also zero. There should be no current across this source. So if I go to the choices, the direct answer is choice number B, because it says the current I2 must be zero. This is that the correct answer. If I go through other choices as well, let us say it says the current I1 must be zero. It says that this current must be zero, which is not possible because it is the driver source and it has to drive a current for all of these things to operate. So I1 cannot be zero. So this is the wrong choice. Next is, it says the PD across YZ should be zero. PD across YZ is 0. If I have this PD across YZ is 0, the PD across XY, then Vxy is whole equal to E at all times. This is not possible because Vxy is obtained by the potential division of this E. There are two resistors, this resistance, and Vxy is only across this thing. So it is obtained by the potential division of E. So we can't have this Vyz always equal to 0 or Vxy always equal to E. That's not possible. Vxy is obtained by the potential division of E. So this condition is never possible. So this C also not possible. Next is the resistance of the external circuit must be 0, it says. The resistance here of this external circuit should be 0. No, it should be infinite. At that time, it should be infinite. That's why this can be set to 0. At that time, at the very time when I2 equal to 0, this resistance should be infinite. That is why this potentiometer is used for. Because if I have to measure the EMF of this source or the PD of this source, we can simply use a voltmeter. But these voltmeters that you find do not provide that infinite resistance. That's why this thing is used. It is used in this condition, this particular condition, when we have this thing, this E is equal to E of this new source. E of this new source is equal to Vxy. At the time, this thing provides infinite resistance. So this should be infinite, and this zero stuff is not possible. So the correct answer choice is choice number B only.